Science. Oh, hey, I didn't see you there. My name is Eric Soderstrom, and I'm a current environmental engineering student here at the University of Vermont. Me and 4 of my colleagues have been tasked together to design a sludge treatment facility for Chittenden County. This here is our video story.
At the beginning of the semester, our team was approached by Josh Tyler, Assistant Engineer and Project Manager at Chittenden Solid Waste District, to design a system to treat the biosolids produced in Chittenden County. Currently, biosolids are transported to landfills in Vermont and New York. By 2020, Universal Recycling Law Act 148 will end the landfilling of organic matter in the state of Vermont. To address this change in legislature, 3 treatment options were investigated: composting, anaerobic digestion, and an emerging technology, gasification. Composting and anaerobic digestion were eliminated because they do not offer the same quality of treatment, and there's a concern about the disposal of end products. Gasification was chosen because this process removes all organic matter and reduces volume by up to 95%. Furthermore, gasification treats for chemicals of emerging concern, such as pharmaceuticals. This provides the best option for protecting the health and well-being of the community by destroying these chemicals, which are not yet regulated by the EPA, but may be in the future. CSWD provided a plot of land located on Redmond Road in Williston, Vermont, to design the facility. After deciding to focus on gasification, the biggest issue became financially justifying such an expensive system. In order to reduce costs, we looked to make revenue by treating biosolids from surrounding Vermont counties. Data research involves soliciting all surrounding counties to determine the percent solids, annual wet ton generation, and current biosolid management practice. To determine appropriate site placement for the future facility, an initial site visit was conducted. As shown, 2 intermittent streams are located on the north and south side of the premises. In order to avoid stream redirecting, permits, and possible water contamination, the building was designed to be built equidistant from both streams. Biosolid gasification is an emerging technology. MaxWest Environmental Systems is currently the only company in the United States which owns and operates a gasification facility. An interview with MaxWest representative Jeff Snyder was conducted in order to get a better understanding of the operation, system lifetime, and costs associated with the plant. Since MaxWest's current facility in Sanford, Florida ties directly into a single treatment plant, it was necessary to create a process design as well as design for an external loading bay, air treatment system, and truck weigh station. The gasifier size was chosen based on current sludge production from Chittenden and surrounding counties. It was determined that a MaxWest 1000 system would be appropriate. The loading bay accommodates 2 standard dump trucks at any time, allowing enough clearance overhead when the truck beds are raised for dumping. A weigh station allows trucks to be weighed before and after exiting the loading bay to determine the amount of biosolids delivered. The ventilation system is designed to maintain 0.1 inch pressure at all times in order to provide a safe working environment and prevent any odors from escaping. A vertical wet air scrubbing unit strips the air of hydrogen sulfide, a chemical that is released from biosolids and can be dangerous at very low concentrations. In order to assess the feasibility of the gasification alternative, a present worth cost analysis was performed. Different gasification scenarios were compared to the do-nothing option, where sludge continues to be dispersed of in a landfill. These analyses were initially performed for a 20-year period, as that is expected operational lifetime of a MaxWest gasification system. These assessments show that the gasification scenario is at least $5 million more expensive over a 20-year project lifespan. Despite this, promising results come from the analysis of the payback period, which is the time window required for the gasification scenario to save money over the do-nothing alternative. A 33-year payback period was calculated for a gasification facility that charges outside counties for sludge treatment and finds a low-cost use for the gasification ash byproduct. Our design and feasibility study has shown that gasification of biosolid sludge has significant environmental benefits as compared to current practices and other treatment alternatives. Though the 33-year payback period calculated during the cost analysis suggests that the gasification alternative could be financially feasible, the capital cost and risk associated with this emerging technology is high. We suggest that the Chittenden Solid Waste District continue with current treatment practices for some time in order to allow biosolid gasification technology to reach fruition and drive down associated costs. A special thanks to Dr. DeWolker and Dr. Pierce for their guidance on this project. Thank you, Josh Tyler, for providing knowledge and support through the project. Finally, thanks to Jeffrey Snyder of Max West Environmental Systems for his help regarding questions about the gasification facility.